Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through everything you need to know for the upcoming test. So all of the topics that we'll go through in the video are listed on your screen. The two topics in red are for the advanced classes only. So let's start with topic 1, which was all about fractions, percentages, and interest. So for fractions, we won't spend a lot of time on this because you can use your calculator in the test. Use that for doing sums like a half plus a third. Just a few points I want to make sure you're aware of. So firstly, of means times. So if I have something like 1/3 of 42, that will be put into your calculator as 1/3 times 42, fraction of a quantity. And so just make sure you know how to use the fraction button in your calculator. The answer you get here should be 14. Let's just do a couple of worded problems. So let's do this question here. So 3/10 have blonde hair, 2/5 of students have black hair, 1/8 have red hair. And we want to find the fraction of students that do not have blonde, red, or black hair. So the important thing to note, fractions are parts of a whole. So here we're viewing the group of Year 9 students as one whole group. So we subtract 3/10 of students that have blonde hair, 2/5 of students that have black hair, and 1/8 that have red hair. And so putting that on your calculator, you should get 9/40. So 9/40ths of the students have brown hair. So just make sure you know how to use your calculator to get that answer. So let's now move on to percentages. So we know that percentage means per 100. So we're going to first look at finding a percent of a quantity. So let's say we wanted to find 45% of 180. So we do this into very simple steps. We firstly convert the percent to a fraction or a decimal. Either one doesn't matter. So we do that by dividing by 100. So I'm going to convert 45% to a decimal. So 45 divided by 100 is 0.45. Now, of means times, just like it did when I was explaining fractions on the previous slides. So 45% of 180 is 0.45 times 180. So if you put that on your calculator, you get 81. That's how I find a percentage of a quantity. So I can use this to help me increase and decrease amounts by a given percentage. So we can actually use these formula here to increase or decrease by a given percentage. So let's say I wanted to increase $180 by 20%. The idea here is what I'm doing is I'm taking $180, which is like 100% of $180, and I'm adding 20% of $180. So that is the same as taking 100% of 180 plus 20% of 180. That's the same as finding 120% of $180. So it's just finding a percent of a quantity, just like we did up here. So using this formula, I can get there quicker. So if I want to increase by 20%, I times by 1 plus 20 over 100. That's the quick way to do it. I just wanted to show you what was going on. So if I times by 1 plus 20 over 100, that's the same as increasing by 20%. And if I put that in my calculator, I'd get $216. So let's say now I wanted to decrease 180 by 25%. So this would be like, if your favorite, video game was on sale for 180 and it was discounted by 25%. That means you're only paying 75% of the price. If I take away 25% of something, there's 75% left. So this is exactly the same as finding 75% of 180. So it's just a percent of a quantity. So using this formula here, 1 minus 25 over 100 is 0.75 or 75%. So I could just go 180 times 1 minus 25 over 100, and I get $135. So make sure you note the difference here. 1 plus, we plus when we're increasing by a percent and minus when we're decreasing by a percent. So now I'm going to quickly show you how to find the original amount in a percentage question. So let's do these questions here. So firstly, in a class, 6 students have blue eyes. 18.75% of students have blue eyes. How many are in the class? So what we're finding is the original amount. So that might not be clear in this question. What we're saying is we've taken some number, so that is the number of students in the class. We found 18.75% of this number, and that has somehow given us 6. So 18.75% of the class is equal to 6 students, in this case, that have blue eyes. So if I want to find what number goes in the box, remember, if I'm finding 18.75% of something, I'm timesing it by 0.1875. 18.75 divided by 100, that's how you convert percentages into decimals. You just divide them by 100. So 0.1875 times however many are in the class is equal to 6. So to find what goes in the box, I undo timesing by 0.1875 by dividing. So I just go 6 divided by 0.1875, and on the calculator that will give you 32. So we're actually finding the original amount. We're finding what number, when we take 18.75% of us, gives us an answer of 6. And the answer is 32. If you take 18.75% of 32, you have 6. That's why that's the answer. So let's look at the second one. So the cost of a suit is discounted by 32%, now costs $544. What was the original price? So again, we're finding the original amount. So when we find the original amount, as we did in this example here, we're always going to divide. So let's say, for example, I wanted to decrease 544 by 32%. Well, what we learned on the previous slide, you would just go 544 times 1 minus, because it's decreasing, discounting, minus 32 over 100. But the question here didn't say discount 544 by 32%. It said we've taken some price, decreased by 32%, and ended up with 544. So instead of timesing, because we're finding the original amount, we're going to divide. So the answer is going to be 544 divided by 1 minus 32 over 100. And that gives us $800. Okay? So we're saying in this one, remember, if you discount something by 32%, you're finding 68% of it. So we're saying 68% of a number is equal to 544. We're essentially doing what we did in the previous question. We're just going 544 divided by 0.68, exactly like we did in the previous question, because this number here is 0.68. So either way you show you're working is fine. The answer is 800 in both cases. So note, you can't just take 544 and increase it by 32%. If you take a number, any number, decrease by 32%, then increase that number by 32%, you're not actually back where you started. You can try that with any number. So we can't just take 544 and increase by 32%. When we're finding the original amount, we always divide. All right, now we're going to move on to interest. So we'll now look at simple interest. So interest is extra money that you owe when you borrow money from the bank, or extra money that you earn when you invest money in the bank. The way we calculate interest is the same, whether it's interest borrowed or earned. So for simple interest, the formula is I, interest, equals principal times rate times time, all divided by 100. So interest, I just said what it was, extra money you've earned or owed when you're dealing with a bank. Principal, P, is what you start with, R is the interest rate, and T is the time. So R and T need to be in the same unit. So the interest rate is usually given as per annum. We say PA to mean that. That actually means per year. So if the interest rate is per year, then T needs to be in the same units. It needs to be in years. So if I invest $4,000 at 5% per annum, simple interest, how much interest would I have after 18 months? So all I'm doing is substituting numbers into this formula. So interest would be principal, what you started with, times the rate, which is 5% per annum, times the time. So I don't times 18 and divide over 100, because then this is in years, this is in months. What I need to do is change T into years. So 18 months is 1.5 years. So if I put that on my calculator, I get $300. So what I've actually calculated is that if I invested $4,000 at the bank for 18 months at 5% per annum simple interest, the bank would give me an extra $300. And after the 18 months, I'd have $4,300 in total. So let's look at this second question. So say I borrow $8,000, 2.5% per annum simple interest for 4 years, what would be my monthly repayment? So to figure out my monthly repayment, I need to figure out how much I need to pay in total. So I'm going to start by calculating interest. So interest equals principal, what you start with, times rate, times time, over 100. So if you put that into your calculator, you should get $800. So what that means is, if I borrow the $8,000 at 2.5% per annum simple interest for 4 years, if I borrow this, I won't pay back $8,000, I have to pay a bit more. The total amount that I must repay is going to be $8,800. I need to repay the $8,000 plus a bit more interest of $800. So I need to pay back that in total. So to figure out how much I need to pay back per month, my repayment, which I'll just call REP, will just be the amount I'm paying back divided by the number of months. So 4 years is 48 months. So if you put that on your calculator, you get approximately $183.33 every month, and we're done. So let's now look at using this formula, I equals PRT over 100, to find PR or T. So let's do this question here. I want my investment of $6,000 to grow to $9,000. The bank offers 4% per annum simple interest, and I want to figure out for how many years I must invest my money. So I'm still using the same formula, I equals PRT over 100. But this time, I'm actually finding T. For how many years, I'm asked to find the time. So when you're asked to find PR or T, what we're going to do is use this formula, substitute in everything I do know, and rearrange to find what I don't know. So if I want my investment to grow from $6,000 to $9,000, I want to earn $3,000 in interest. I equals 3,000. So I'm going to substitute I for 3,000. Now P, the principal, is what I started with, and I was told the rate is 4% per annum. So this is the equation that I need to solve. I need to solve this equation for T. So what I could do now, just to make this easy to work with, is I'm just going to put this in my calculator. I'm going to put everything except the T. So I've still got my 3,000 of interest, but if I put 6,000 times 4 divided by 100, I get 240. So this whole thing here on the right-hand side is 240 times T. This is a very easy equation to solve. I undo timesing by 240 by dividing each side by 240. So T will just be 3,000 divided by 240. So if I put this on my calculator, I get T equals 12.5. Because the interest rate was per annum per year, that means T is in years. It's 12.5 years, or 12 years and 6 months. All right, let's now look at compound interest. You can skip this if you're not in one of the advanced classes. So now we're going to look at calculating compound compound interest. And we have a totally different formula here. A equals P 1 plus R over 100 to the power of N. So note, in the previous examples, when we use simple interest, the formula calculated the amount of interest. This one calculates the amount you have in total, but it's really easy to figure out the interest from that, which I'll tell you in a second. So P still means principal, R means rate, and N is the number of compounds. But here we need to change R and N. They need to be in the same units as the compound frequency, which I'll explain in a moment. So what's going on here is, if you have simple interest, if we look at a graph, simple interest means the amount you have, or the interest you're earning, goes up by the same amount each time, like each year. So simple interest, which I'll call SI, is this blue graph there. But what happens with compound interest, it's the same for the first year, but it gets bigger faster. It increases at an increasing rate. So for simple interest, the amount that you have might go up by, say, $300 a year. But what will happen with compound interest, it'll go up by $300 in the first year, then it might go up by $330 in the second year, then by $363 in the third year, and so on. Compound interest, which I'll call CI, gets larger a lot faster. So when we say compound, it's like when you have like a compound fracture. It's like a fracture on top of a fracture. For compound interest, you earn interest on top of the interest. So what we say when we say the interest is compound, what we do is we recalculate how much money you have. We can recalculate how much money you have every month, every year, whatever. So that's what I mean by compound frequency, and N, the number of compounds, the number of times you recalculate how much interest there is. So let's say I invest $12,000 at 4.8% per annum interest for 3 years. We're going to figure out how much interest I would earn if interest is compounded annually or if it's compounded monthly. So we're going to use this formula up here. So if it's compounded annually, the amount that I will have is equal to P, the principal, so that's how much you started with, times 1 plus R is 4.8 over 100 to the power of N. So N is the number of compounds, the number of times I recalculate interest. So if you do it annually, which means yearly, for 3 years, you do 3 times. You compound the interest 3 times. So I can just put this straight on my calculator. So the answer I get is approximately $13,812.27. But that isn't the interest. That's the amount I have in total. So the interest is how much extra I've earned. So I started with $12,000. I finished with $13,812. So that means I've earned in interest $1,812.27. It's just this minus this. How much I end up with minus how much I started with. So that's if interest was compounded annually. It turns out we'll get a different answer if interest was compounded monthly. That is, if we recalculated the interest every month. So we're still going to use the same formula, A equals P, but this time the rate is 4% per annum, but we need to find the rate per month. So 4.8% per annum is actually 0.4% per month. So because there are 12 months in a year, I need to divide the yearly rate by 12. So that's 0.4% per month. I also need to change N. N is the number of compounds. If I compound it monthly, every month for 3 years, I'm going to compound it 12 times a year, 24 times in 2 years, and 36 times in 3 years. So what I put on my calculator is 1 plus 0.4, that's the rate per month, over 100 to the power of 36. And this is what I put in my calculator. So putting this in my calculator, I get 13,854.63. That is not the interest, that's how much I have in total. So the interest will be $1,854.63. So the interest was a little more when it was compounded monthly than when it was compounded annually. And if you keep the interest rate the same, the more frequently you compound, the more money you have. All right, let's now move on to Pythagoras' theorem. So Pythagoras' theorem concerns right-angled triangles. Pythagoras' theorem says that a squared plus b squared equals c squared. So a and b are the two shorter sides of a right-angled triangle, and c is the hypotenuse. It's the longer side. The longer side of the right-angled triangle always faces the right angle. So Pythagoras' theorem helps us find unknown sides in right-angled triangles. So we can rearrange this formula here. So if I want to find C, the longer side, I just can square root both sides. If I want to find, say, A, one of the shorter sides, it would be the square root of C squared minus B squared. So you'd use this formula here if you wanted to find the longer side, which is the hypotenuse. And we use this formula here if we want to find one of the shorter sides. So let's look at some examples. So we will now use Pythagoras in each of these triangles to find the unknown side. So let's look first at this triangle here. So now we're finding the longer side. We don't need to measure anything. We know this is the longer side because it's facing the right angle. So we're going to use this formula here. So here, x will just be the square root of shorter side squared plus shorter side squared. You can put that straight in your calculator and you get 15 meters. How easy is that? So let's look at this one now. So x is now one of the shorter sides. We know that because it's touching the right angle. It's not facing the right angle. Here 20 centimeters is the longer side. So because we're finding a shorter side, we use this formula here. So x will just be the square root of longer side squared minus shorter side squared. So it's important that C goes first in the square root. The hypotenuse, the longer side, goes first. Otherwise, you'll get an error on your calculator. So if you put that on your calculator, this time you don't get a whole number. So to 2 decimal places, it's about 17.32 centimeters. So sometimes you get a whole number, sometimes you don't. So let's look at this one here. We are now actually going to find each of the two shorter sides. This is a right-angled isosceles triangle. Isosceles means it has two equal sides. So let's call this unknown side A. This one here will also be A. So this is an exception. Normally, we can just skip straight to one of these formula rather than going through and substituting into this equation here. We can do that when we're only finding one side. But here we're actually finding two sides at once. So this is an exception. In this case here, we can't skip straight to one of these formula. So what we have to do is substitute here into this formula a squared plus b squared equals c squared. So what we have is shorter side squared plus shorter side squared equals hypotenuse squared. So a squared plus a squared is 2a squared. 16 squared is 256. Now we want to solve this equation for a. So we need to undo what's been done to a. Order of operation says that a is squared first, then multiplied by 2. So we need to undo multiplying by 2 by dividing by 2 first. So a squared is 128. Now we undo squaring by square rooting. So when you're finding a side using Pythagoras, you should always square root somewhere. So a would be the square root of 128, which in this case about 11.31 centimeters. Okay, so this one we just did a bit differently because we're finding two sides at once. So let's now look at some more problems involving Pythagoras' theorem. So let's have a go at these two worded problems, both involving Pythagoras. So if you're given a worded problem involving Pythagoras, it's best to draw a diagram if you're not given one. So let's look at this first one. What would be the area of an equilateral triangle with side length 4 centimeters? So let's draw that. So if we have an equilateral triangle, that means all sides and all angles are equal. So it looks like this, and each side here would be 4 centimeters. So remember, to find the area of an equilateral triangle, it's the base, which we know is 4, times the perpendicular height divided by 2. So you're probably thinking, well, okay, what does Pythagoras have to do with area, and what does it have to do with equilateral triangles? Well, what we can do is we can divide this into two right-angled triangles. They're actually congruent. So we can actually use Pythagoras to find this height here, which I call h. And then area is just base times height divided by 2. So that's how Pythagoras can help even in an equilateral triangle. So let's find out what h would be. So we know this whole length here is 4. This length here will be half of that, which is 2. That works for isosceles and equilateral triangles. So h is just going to be the square root of... Now, h is a shorter side in this right-angled triangle, so we minus. It will be the square root of 4 squared minus 2 squared, or the square root of 12. So that is approximately 3.46 centimeters. So what we do now to find the area, that's easy. It's just the base, which is 4, times the square root of 12 times the height, all divided by 2. So if you put that on your calculator, you get about 6.93 centimeters squared. So Pythagoras enabled us to calculate the area of this triangle by calculating the perpendicular height, because the height is at right angles. All right, let's do this question now. Ladder leans against a wall, ladder 5 meters long, and the base of the ladder is 2 meters from the base of the wall. How far up does it reach? So this is pretty hard to understand what's going on without a diagram. So let's draw one. So what we have is some wall, which you can assume is at right angles to the ground. So then we've got a ladder leaning against the wall. So the ladder's 5 meters. The base of the ladder, the bottom of the ladder, is 2 meters from the base of the wall. So if I want to find out how far up the wall it reaches, I'm just finding this distance here, which I'll call x. So once again, x is a shorter side, so it will be the square root of 5 squared minus 2 squared. Again, we're minusing because we're finding a shorter side. So if we put that on our calculator, I'll give it to 2 decimal places, so it will be about 4.58 meters. So what we're doing is we're just taking real-world applications and turning them into right-angled triangle questions. Remember, we can only use Pythagoras to find the unknown side in a right-angled triangle. So whenever you get a worded question like this, you should end up drawing a right-angled triangle and finding an unknown side. All right, the last thing we have to do in this topic is Pythagoras in 3D. So here we have a rectangular prism, and we can use Pythagoras to find the longest stick that would fit inside the rectangular prism. So that's from bottom corner of one side to the top corner of the other side of the rectangular prism. So we can figure out what this is. So I'm going to call this distance here x. I can figure out x using Pythagoras. Now, I need x to be a part of a right-angled triangle, but it's not. So what I can do is I can actually find this distance along the bottom of the rectangular prism, which I'll call y. And then I'll have a right-angled triangle here. I know this will be a right angle because it's a rectangular prism. And using that green triangle, I can find x. So let's first calculate y. So y is along the bottom of this rectangular prism. So because it's a rectangle, this will be a right angle. Y is the longest side of this right-angled triangle. So it will be equal to the square root of 6 squared plus 5 squared. We're adding because we're finding the longest side. So 36 plus 25 gives you the square root of 61. Y is the square root of 61. Now, I don't want to round my answer here because I need to use y in my calculation to find x. So now, if I look in this triangle, I now know 2 of the sides. I know this is the square root of 61, this is 8, so I can find x, which is the longest side. So x will be the square root of y squared plus 8 squared. and that will give me the square root of 125. So putting that on my calculator, I get about 11.18 centimeters. So I use Pythagoras twice to find x. Note, there's a quick way to do these kind of questions when you're finding the diagonal of a rectangular prism, the longest stick that will fit inside a rectangular prism. So what I could have done is just find the square root of the squares of the three dimensions. So I could have just gone square root of 6 squared plus 5 squared plus 8 squared. So you can do that, and I would have got exactly the same answer down here. So that's just how you find the diagonal of a rectangular prism. All right, last topic now, we'll go through linear relations. So we're going to start off with 2 points here. You should be familiar with points that look like this. So the first number is the x-coordinate, and the second is the y-coordinate. So we're going to start by plotting these points on the Cartesian plane. So remember, for our Cartesian plane, x is the horizontal axis, y is the vertical axis. So let's plot this point A. So we go across to x is -2, up to y is 3. And we'll put a dot there. So that will be point A. So then B is the point 3 minus 9. So we go across to 3 for the x value and down to -9 for the y value. So if we join up these points, what we have is called a line segment. So a line segment has a start and an end point, whereas a line goes forever in both directions. So this is a line segment. So what we're going to do now is calculate the distance, midpoint, and gradient of this line segment. So let's start with the distance. So what we're saying is, how far is it from A to B? So we can just use Pythagoras for this. What we can do is make this into a right-angled triangle. We know it's right-angled because the x and y axes are at right angles. So we can easily figure out this distance here. We've gone from 3 down to -9. So the distance we've gone is 1, 2, 3, and then a further 9. This distance here is 12 units. Similarly, we can figure out this distance really easily. We've gone from x is -2 to x is 3. We've gone across 5 units. So the distance, we're just finding the hypotenuse of a right-angled triangle. It's just the square root of 12 squared plus 5 squared, and that gives us 13 units. So that's the distance from A to B, 13 units. We don't actually know whether it's 13 centimeters, meters, whatever. It doesn't matter. It's just 13 units. So next, let's find the gradient. So the gradient is a number that indicates how steep the line is. The higher the number, the higher the gradient, the more steep the line is, which means the more vertical it is. So the gradient is the rise over the run. So you need to find the gradient between 2 points A and B. So what we're saying is, to get from A and B, how far do we go up or down? How far do we go right? So from here to here, we've gone right by 5 units. So 5 will go on the bottom of our gradient here. Now to get from A to B, so you always start at the left point. We've gone right 5 units. Now, have we gone up or down to get to B? We've actually gone down by 12 units. So the gradient is going to be 12 over 5, but because we've gone down, the gradient's negative. That's what this note here means. So we always start at the left point, and we always go to the right. If we go up, if we go to the right and up, the gradient is positive. If we go to the right and down, the gradient's negative. So in this case, the gradient was negative because we went to the right and down. So the gradient is -12 over 5, or -2.4. Again, that just indicates how steep the line is. So we'll now find the midpoint of this line segment. So that is exactly what it sounds like. what we're finding is the point along here, it's going to be somewhere along here that is halfway along the line segment, halfway between A and B. Now, you won't always be able to just see what the midpoint is just from looking at this line. It's hard to get it exactly halfway. So what we can do is we can use this formula. So the midpoint is a point. It needs an x coordinate and it needs a y coordinate. So to find the midpoint, you take the average of the x values and the average of the y values. So this doesn't mean x squared. What this means is x coordinate of the first point, x coordinate of the second point. So x1 is the x coordinate of point A, x2, y1, y2. That's what we mean here. So to find the midpoint, the middle of the x values, we just add these two together. So we add minus 2 and 3 and then divide it by 2. So minus 2 plus 3, adding the two x values, dividing by 2. Similarly, we add the two y values and divide by 2. So we go 3 plus minus 9 over 2. So you can put that in your calculator and you'll get 0.5 minus 3. So what that's saying is the midpoint would actually be here. Around 0.5 is the x coordinate and minus 3 is the y coordinate. That is the point that is halfway along the line segment here. So make sure you remember the formula, but it's just very intuitive. You're just adding together the two x values, dividing by 2, adding together the two y values, dividing by 2. Just taking the average of the x values and the average of the y values. So I said before A and B is a line segment. So we need to know how to find distance, gradient, and midpoint of a line segment. But what happens if we extend this in both directions so it goes forever? This is now a line. We need to know how to find the equation of a line. So it turns out the equation of any line can be written as y equals gradient times x plus whatever the y-intercept is. So we know what gradient is. It's the rise over the run. The y-intercept is just where the line hits the axis. So we know here the gradient is minus 12 over 5. So we know the equation of this line is going to be y equals gradient times x plus the y-intercept. So we need to figure out how to find b, the y-intercept. So the y-intercept, you're not always going to be able to just look at a graph and see it. So it looks like it's minus 2 here, but we can't be sure. It could be like minus 1.99. So this is how we figure out the y-intercept when we've got the gradient. What we're going to do is we're going to substitute in x and y, and then rearrange to find b. So how do I know what x and y equal? What you do is you substitute in either point. It doesn't matter whether I use point A or point B. So I'm going to substitute in point A. I'm going to substitute x for minus 2 and y for 3 into this equation. The whole point is I want to find b, what the y-intercept would be. So if I substitute y for 3 and x for minus 2, I get minus 12 over, 5 times x, which is minus 2, plus b. So if I were to put on my calculator minus 12 over 5 times minus 2, what I actually get is 4.8. So 3 equals 4.8 plus b. To get b by itself, I just subtract 4.8 from both sides. So here, it turns out the y-intercept is actually minus 1.8. So it's just above minus 2. Of course, my scale here wasn't accurate. So the equation of this line is y equals gradient times x plus y-intercept. That is the equation of the line that goes through these 2 points. Alright, sorry for the long video. Thank you so much for tuning in. Best of luck studying, but you're a superstar and you'll ace it. There's still heaps of time for questions, so please let me know. This has been the luckiest maths teacher in the world. Have a great day.